Up until this point, all of the examples we've shown have run Docker on a single host. In production scenarios, we would likely be running our distributed applications across multiple hosts. We can only scale a single node so far, so Docker provides another tool called Docker Swarm, which allows us to run containers across a group of Docker hosts. Docker Swarm is an API that is compatible with the standard Docker API, which allows clients to run containers on multiple hosts as if it were a single host. The fact that the API is compatible with Docker's API means that you can still use standard Docker client to control a swarm. Once you go multi-host with Docker, you need a backing key value storage mechanism to keep track of the available nodes. There are a few options to choose from, such as Consul, etcd, or Zookeeper. For purposes of this course, we'll use a single Zookeeper instance running on our Docker host. We now have a Zookeeper instance up and running and available on port 2181. We can now start up a Docker Swarm Manager, or master instance, on our Docker host. Docker provides a Dockerized version of the Swarm executable simply named Swarm. Swarm takes a number of parameters, which we'll show in a moment. Let's start up the Swarm container to manage our cluster. Here, we've used the -v option to mount the directory containing TLS certs into the container running Swarm Manager. We've added RO to the end of our mount to indicate that it's read-only to the container. Next, we've specified that we're running the official Swarm image. The Swarm image accepts an argument, which tells the executable which mode it's running in. The argument we use here is manage, which tells the Swarm executable to run in manager mode, or as the Swarm master. Next, we'll use the -h option to specify the IP and port to bind to. The default port for a Swarm manager is 3376, and we can use 0000 to bind to any public interfaces. Next, we need to specify a few TLS options to allow for secure communication with any Swarm nodes. Since we mounted varlib boot to Docker to the certs directory in the container, we can point to it for our PIM files. Since we started Zookeeper on the default Docker host, we need to pass the URL to Swarm. Zookeeper URLs use ZK as the protocol and by default run on port 2181. For this example, we don't need to specify a path within the Zookeeper to use though. So now our Swarm manager is running on the default Docker machine. The next thing we need to do is add some Swarm nodes. The Swarm nodes will be managed by the Swarm manager and will run any containers in the Swarm. We can create another Docker host using Docker machine create. We can name our node Node1. Next, we need to point our Docker client at the newly created Docker host. On this new Docker host, we need to run the Swarm executable again, but this time using the join argument. This will cause the Swarm process to register itself in Zookeeper, making it discoverable to the Swarm manager. Swarm join accepts an option adder, which refers to the address of the Docker API running on the Docker host. By default, the secure Docker API runs on 2376, and we can use Docker machine IP to get the new Docker host's IP address. Once again, we need to pass in the Zookeeper on the default Docker host's URL. Our Swarm node is now running, so let's create one more. Once again, we need to join this node to the Swarm cluster. Now we have a Swarm cluster of size 2, and now that we're up and running, we can point our client at the Docker Swarm API running on the default Docker host. Our Swarm manager is running on port 3376 instead of the normal 2376, so we'll need to manually point our Docker client at it. Instead of using Docker machine to do this, we can simply set the Docker host environment variable to our default Docker host IP with port 3376. Now, if we run docker info, we'll see the state of our Swarm cluster. In this output, we see information specific to Swarm. Most importantly, we see the two nodes, Node 1 and Node 2, that we started up. We can also see that they're both healthy. So let's run a few containers against the Swarm manager. Remember, we can use the Docker client with Swarm the same as if we were working with a single Docker host. We can run our Hello O'Reilly HTTP image a few times on the cluster by using docker run. We've run a few Hello O'Reilly containers. Let's run docker ps and see them running on the cluster. Just like on a single node, we can run docker ps against a Swarm manager to see all of the containers running across the cluster. We can see that all three containers show up in docker ps, but you'll notice that each name is prefixed by the node name. Our containers were automatically spread out across the nodes by Swarm. You can see under the ports column that the containers span different IP addresses. Next, we'll run another Swarm cluster and set up a multi-machine overlay network so that we can deploy containers that can actually communicate with each other.